Hey everyone, welcome back to Math 20-1. We will be going through lesson 4 of the quadratic units, and this is completing the square. Remember to stop the video anytime to take notes or to contact your teacher if you need help. So let's get started. We're going to start by doing a little bit of a review of perfect square trinomials. You first saw these in Math 10C, and a perfect square trinomial is one that has 3 terms in it. And it can be expressed as the square of a binomial. And a binomial has 2 terms. And in general, perfect square trinomials can be written as a sum, like a plus c squared. And notice if you FOIL those out, you get a squared plus 2ac plus c squared. And the a and the c, they can have constants or coefficients. So a and c can be constants. They can be a coefficient with a variable, and that could be something like, 3x could be a or c. Or they can even have different variables, be like 4y. And the thing about the perfect square is that the first term and the last term are perfect squares of a and b. Well, that says b, that should be c, respectively. And the second term is double the product of the square roots of the first term. In other words, if we take the square root of a squared, we get a. And the last term, we get the square root of c squared, which is c. The middle term is going to be 2 times a times c. So let's look at an example. We're going to look at x plus 3 squared. Well, to do this, we say x plus 3 times x plus 3, and we FOIL it out. First, outside, inside, last. That's going to give us x squared plus 3x plus 3x plus 9, and simplifying it, we get x squared plus 9. Now notice the middle terms in the square root is the square root of the first term times the square root of the last term. This should be term. So 2 times the square root of x squared times the square root of 9, which is the last term. That equals 2 times x times 3, which equals 6x. And I just want to note here before we move on that the little dot we're using is for multiplication. Because we are working in the variable x, we don't want to confuse the multiplication sign with x. So let's move on. So for number 1, it's asking us to identify the trinomial that is not a perfect square. And hint, remember the middle term is equal to, and let's write it in, 2 times the square root of the last term, or in other words, or the first term, which was a squared, times the square root of the last term, which is the square root of c squared. So let's start by figuring out if we take 2 times the square root of the last term and the first term, do we get the middle term? So for this one, a, I'm going to say 2 times the square root of x squared times the square root of 25. Well, that gives us 2 times x times 5, which gives us 10x, which means this one works. Let's look at the next one. For this one, we get x squared minus 4x plus 4. So we're going to do the same thing. Take the square root of the first one, times the square root of the second one, and that gives us 2 times x times 2, and that gives us 4x, which is what the middle term is. And in this case, it's good to note that we're not worried about the sign. We just want to know if the numbers work. Now let's try this one. We get 2 times square root of x squared times the square root of 10. Well, that equals 2 times x times 10. And 2 times 10 is 20. So we get 20x. And the last one, x squared minus 2x plus 4. We get 2 times the square root of x squared. Notice we do that all the time. And because the other three were perfect squares, I'm assuming this one is not, times the square root of 4. And that gives us 2 times x times 2, which gives us 4x, which means this one is the one that's not a perfect square trinomial. So let's use that standard form of perfect square trinomials to do some factoring with example 2. We know, and we can write it out again so that we have it in front of us, a squared plus 2ab plus, let's go with c here, plus c squared equals a plus c all squared. And we can also do the same if the second term is subtracted. So we have these two options. So let's look at A. So for A, x squared plus 10x plus 25, we can say that A is the square root of x. So A equals the square root of x squared, and that equals x. So we know our A is x. Our C is the square root of 25, which equals 5. So writing this down as a factored pair, we could say it's x plus 5 times x plus 5, which is just x plus 5 squared. Now for B, notice we have a 4 in the front. Don't get worried about that, because remember our A is still going to be the square root of the first term. And remember our exponent laws, when we have a coefficient in front, we take the square root of the coefficient, in other words, the square root of 4, which is 2, and the square root of the variable, which is the square root of x squared, which is x. So now we have an A, and it's okay for the A to have a variable with the coefficient in front. And then C is the square root of 16, and that equals 4. And because this is subtraction, this is going to be the binomial 2x minus 4 times 2x minus 4. And that's going to give us 2x minus 4 squared. The way you can check these are right is by to take these ones right here and to apply the FOIL rule. First outside, inside last, and to make sure you end up where you started with. If you don't, go back and check it to see where you made your error. Now, this lesson, as we said at the beginning, is about completing the square. And why do we want to do this? Well, you recall from the previous lessons that vertex form of a quadratic equation gives us a lot more information than standard or factored form. And if we can get a quadratic into vertex form, we can tell a lot of things about it. We can immediately determine the vertex of the equation, maximums, minimums, domains, ranges. a lot more than, say, the factored form, which really is limited to the x-intercepts and kind of the orientation of it. In other words, the concavity, or standard form, which gives us the y-intercepts and the concavity. So the problem we have is not all equations, though, are in vertex form. Well, the solution would be to convert quadratic equations to vertex form so that we can get all the information about the graph. Now, the process of converting an equation into standard form, or from standard form to vertex form, is known as completing the square. And that's what we're going to do right now. Now, the steps for completing the square, there's a few of them. And we do have to kind of remember the steps. And that was going to take practice. So don't be nervous if this first time things aren't clicking right away. It will take a couple times to get through this to make sure that you understand what is happening here. So let's start with a quadratic that is in standard form. Y equals ax squared plus bx plus c. And we're going to use the example to work through, as we explain it, of y equals 2x squared plus 4x plus 3. Some of these steps are going to seem strange at first, but as you go through, you'll see how nicely it works out. So the first step after making sure our quadratic is in standard form, because sometimes they write them without the ax squared term in the first. Maybe this is the second term, and we want to have it arranged so that we have the exponents in descending order, meaning the highest exponent first to the lowest, and the constant at the end. Once that's done, we are going to group the first two terms and then factor out the value of a. What does that mean? Well, notice what I did here. I put the first two terms in brackets, and then I factor out the 2. So now inside the bracket, I have an x squared plus 2x. And notice that this new 2, we're going to call that b, but it's not the b of standard form. It's a new b. So, and I want this to be clear that these two b's are not the same. In other words, this b is not the same as this b because we have taken a out. Then the next thing we're going to do is we're going to take that new b, divide it by 2, and we're going to square it. And this is going to, don't worry right now, this is going to be a good thing. We're going to show why this is going to work. So in this case, my b equals 2. That's the term that I've brought down from here. I'm going to put that over 2 and square it. Well, 2 divided by 2 is 1 squared, which is just 1. So I have this new number. What am I going to do with that number? Inside the brackets, I'm going to add it and subtract it. And why am I doing add and subtract? Well, because we do not want to change the expression. And by adding and subtracting 1, really what I've added is 0. So I've just changed the way it looked, but I haven't changed the overall. So it just looks different. So then what I'm going to do is I am going to bracket off the first 3 terms. Now this first 3 terms right here, by adding and subtracting that b over 2 squared, this one actually becomes the perfect square trinomial. This is not magic, and at the end of the lesson, we'll explain why this works. So now that I have this perfect square trinomial, I'm going to write it in factored form. And that's this one right here. And for the last step, I'm going to simplify. I'm going to distribute the 2 inside the brackets. Now notice the 2 is applied to this term and it's applied to this term, but not to the 3. Okay, it doesn't get applied here because it's a constant on the outside. So I write the 2 times, the first term is that whole binomial, so 2 times x plus 1 squared. The second term is 2 times negative 1. So 2 times negative 1 is negative 2. So I have 2 times x plus 1 squared minus 1. Now I have a quadratic in vertex form where y equals 2 times, or not 2, let's put it in this, in the general, 2 times a times x minus p squared minus 1. And in this case, my p equals negative 1, my q equals negative 1 as well. So let's use our newfound method to convert some more things into some more quadratics into vertex form. So let's start with some examples here. In example 1 here, we're going to complete the expression to make a perfect square trinomial. So now that we know to make a perfect square trinomial, we take the b term or the middle term, what we want to be the middle term, we divide it by 2, and we square it, and we add that to the end. So let's do that for this one right here. Well, the b in this case equals 14. So I'm going to say 14 over 2 squared, which equals 7 squared, which equals 49. So here our answer is 49. For the next one, our b equals 2. And this one is just like the one we did above. 2 over 2 squared equals 1 squared, which just equals 1. And for the last one, we're going to say b equals 18. We don't really need to have the negative at this point. And the reason is because we actually square it and any negatives would go away. So we say 18 over 2 squared equals 9 squared, which equals 81. So let's look at example 2. Complete the square for y equals 8x 8 squared plus 8x minus 7. So I'm going to go ahead, and because it's already in descending order, I don't need to change anything around, and I'm going to bracket off the x squared plus 8x. It's actually step 2 because everything is in standard order, but we'll just call it step 1. Now for the next one, we're going to pull out the any factoring that can be done with the coefficients of x squared and 8x. In this case, there's only a 1, so I don't need to write anything out for step 2. The thing I do want to do, though, is I want to take my b that equals to 8, I want to put it over 2 and square it to get the term that I'm going to add and subtract inside the brackets. And in this case, I get 4 squared, which is 16. So I say y equals x squared plus 8x plus 16. And notice I didn't stress it in the instructions, but the positive has to go first. And I'm going to bracket off this term, 3 terms right here, and that's going to make the perfect square trinomial. So I say y equals, now that is x plus 4 squared. Now notice here, because I don't have the coefficient out front, I don't need to run or distribute it through. So I'm really left with this, which means all I have to do is simplify by subtracting 7 from 16, and it gives me 23. So this one is the completed square. Let's move on to number 3. Now this one here, notice is like, now let's look at number 3. Now this one is a kind of presented to you like a numeric response question. When y equals negative 3x squared minus 18x minus 4 is written in text form by completing the square, the result is y equals, look at here, it says it's going to be a negative a, so that's going to give us some information here. X plus b, so we know that the value in here is going to have a positive, plus a 2-digit number on the end. So this is giving us a lot of information right here, and that's going to help us to make sure we don't make any mistakes if we don't have a negative a, positive b inside, and a 2-digit number on the end. So let's start by bracketing off the first 2 terms. And remember to keep the negative 4 on the end. I sometimes drop it, and so then I end up with something that's not right. Now, the first thing, I'm going to take out a negative 3. And that negative right here was kind of a hint that that number I should take out is negative. So I take out the negative 3. I get x squared plus 6x. Now, in this case, my b equals 6. So my 6 over 2 squared, that's a 6. That's a really bad 6. Is 3 squared, which is 9. So I'm going to add and subtract 9 inside those brackets. I'm going to convert the first 3. I'm going to put those in brackets, and that is my perfect square trinomial. And at any time, if you have doubt, you can take that, remembering all the brackets here. You can take this, FOIL it out to make sure you end up back with this trinomial. And then we're going to distribute that 3 through only these terms. And that's going to give us negative 3 times x plus 3 squared, and negative 3 times negative 9 is a positive 27. And we're going to subtract 4. So far, this is looking good because my a is negative, my b is positive, and sure enough, those last 2 numbers add together to make a 2-digit number. So 27 minus 4 is plus 23. So in the squares, I'm going to put a, which is 3, b, which is 3, and cd, which is 2, 3. Let's keep going. We're going to go ahead, and if you are a synchronous or asynchronous student, I want you to do questions 2A and 3E, take a picture, and I want you to email them to your teacher. I want you to show them that you know how to do these completing the square questions. Okay, let's move on to example 4, where it's asking us to rewrite the function g of x equals negative 2x squared minus 16 minus 15 in vertex form, and state the axis of symmetry of the parabola. How could you check that you've done this right? Well, let's go ahead and start by converting. We know g of x equals, first thing we're going to do, we're going to bracket off the first two terms. The next thing we're going to do is we're going to take out a common factor. In this case, I'm going to take out a negative 2. Notice when I take a negative 2 out of negative 16, that turns to a positive. And then I'm going to find what I'm going to add and subtract. Well, my b value equals 8. So my b over 2 squared equals 16. So I'm going to add and subtract 16. Add 16, subtract 16. And don't forget our 15 here on the end. I'm going to bracket off the first 3 terms inside the other brackets, and that's going to be my perfect square. So remember, the perfect square is the a value, which is the square root of x squared, which is x, and the square root of 16, which is 4. Notice to keep the brackets at this point because we still have to distribute the 2 through those terms there. And that's going to give us negative 2 times x plus 4 squared, and then negative 2 times negative 16, which is positive 32. Running out of room, let's go up. And we get g of x equals negative 2 x plus 4 squared, and then 32 minus 15, that's plus 17. And it's asking us to state the axis of symmetry. Well, remember in standard form, and I'll write it out, the axis of symmetry is when x equals to p. Now the p value for us is negative 4, because remember we have to flip the sign. So in this case, the axis of symmetry is negative 4, and this and I'm just going to write axis of symmetry here. I spelled symmetry wrong. Don't judge me. I'm a math teacher. Okay. So let's move on to example 5. Here we have a word problem. And it says a soccer ball is kicked into the air from the top of a picnic table, and the function h of d gives the height of the ball in feet as h of d equals all of that, where d represents the horizontal distance. So in other words, if you kind of think it, if you've done physics, this might, it's going to look something like this, where on this axis is the d, on this axis is the height. Physics students do this a lot. And we're going to determine the maximum height of the ball without graphing. Well, we know the maximum height of the ball is the vertex. So if we could figure out the vertex, we could figure out the y value of the vertex, and that would give us the maximum height. Well, in order to do that, we need to go ahead and complete the square. And you're probably thinking, wait, that has a decimal in it. Don't worry, it's a special decimal. So first thing, bracket off this right here. Now, we have to take out the A, and the A in this is going to be that weird decimal. So we have to take that out. And now that part is not too bad, but we're like, well, what about this D here? Well, remember, that D is a 1. So think of it this way. I have this A value here that I would have to multiply back to 1D. So in other words, negative 0.025 times some number n has to equal 1. That has to equal that. So what we're going to do, we're going to divide both sides by 0.025 or negative 0.25. In other words, I'm going to divide 1 by this number. And let's break out a calendar. Let's break out a calculator and look at what we got. Well, we want 1 divided by 0.025. Oh, and it should have been a negative, so that would make this negative 40. It's not too bad, not too bad. And so we get negative 40D, like that. And don't forget the plus 3. Now we need to get our b over 2 squared number to add and subtract. Our number is 40 over 2. Now 40 divided by 2 is 20, and squaring that, we get 400. So what I'm going to do over here is I'm going to say d squared minus 40d plus, don't get scared of the big numbers, you got this, where this is our perfect square. I'm going to go ahead and write this out. And now we're going to write the first 3 terms as the perfect square trinomial in the factored form, which is going to be x minus, because this is a minus, in remember in these trinomials that the first term tells you what goes between the binomial. In this case, it's x minus 20 squared minus 400, and don't forget the lonely 3 on the end. Now we're going to take this thing and we're going to FOIL it through the first 2 terms there inside the brackets, and that's going to give us negative 0.025 x minus 20 squared. And now we have to multiply that 0.025 times that 400. So 400 times 0.025 that is going to give us 10. And because it's a negative times a negative, it's a positive 10. See, that wasn't so bad. And then we're just going to go ahead and gather up those like terms at the end. And now we have a very pretty polynomial in factored form. But the question asks, determine the maximum height. So that means I need to know what is P and what is Q. Well, in this case, the P is 20 and the Q is 13. So this is the vertex, which means the maximum height of the soccer ball is 13 feet. And I know we got 13 feet here because here it says feet, so we need to have feet here. And 13 comes from the vertex. Okay. And the last question. The work in the table below shows one strategy for completing the square using a general function f of x and a specific function g of x. So really what they've done is started in this general form, have gone through, taken the b. Notice when they pull out the a, the only way this is going to work is if the b is divided by a. So look at this. I can take this just to make sure if we go back like this, a times b over a brings it back to b. So this is why when we pull out an a, we divide the second term by b, just like our example up here. We divided the 1 by this, same thing right here. And the same thing happens over in our example right over here. Notice we took out the 2 from the first two terms, and really what we're doing is 32 divided by 2 is 16. So that's where that comes from. They've taken the middle term, which is b over a times x, plus, now look what they did here. They took half of the b over a, and then they squared it, and then they subtract the square of that here. And look, there we go. We got b over 2a minus b over 2a. And then we went ahead and notice that they have taken, theirs is a little different. They have distributed the a through this term and then this term. So it's a times the trinomial plus c, and then it's a times the negative b squared, and so then they stuck that one on the end right here. And then they converted the trinomial to the perfect square binomial, like squaring the binomial. And then we have c minus b squared over 4a. And then here, look what they did here. This one is finding a common denominator on the c so that they can be put together. And because we needed, we multiply top and bottom by 4a, and so we get the 4ac minus the b squared over 4a. And with this, they repeated the process using the same thing on the right-hand side. So let's look at it closely. We've already talked about they pulled out the 2, and we get x squared plus 16x. Then they've added and subtracted 64 because half of 16 is 8, and when we square that, we get 64. And that brings us back to this right here. They're adding this, and then they're subtracting this. Okay, so now we're going to take that 2, we're now going to put together the trinomial. Now they do it a little bit different order. Remember, it's okay. They have distributed the 2 here and here to become 2 times taking that binomial here and squaring it, multiplying this out, and then simplifying at the end. Now, the first question, it asks, write the x-coordinate of the vertex for each function f of x and g of x. What do you notice about the x-coordinate for the general function of f of x? Have you seen this before? Okay, well, let's start with g of x because we know that. For g of x, if we want to find the vertex, remember, is PQ. Well, our P in this case is -8. Remember, it's opposite the sign we see. And the Q is -23. But what about on this side? For f of x, our P value is -b over 2a. And our Q value is 4ac minus b squared over 4a. And you might notice that you've seen the x before. We have learned that the axis of symmetry, or the x-coordinate of the vertex, in previous lessons just equals that. Now, one thing you all missed, so some of you may be noticing, depending on if you've done the course before, this might also look familiar. We'll be looking at this a little later on. It's going to look similar to this, and you'll go, hey, I saw that before in the completing the square lesson. Okay, let's look at part B. It's asking how could we use the x-coordinate of the vertex in general function, so the f of x, as a formula to find the vertex of this special function from the standard form, so without converting into vertex form. Well, we're going to use our little equation to find the x-coordinate. That's going to be -b, and our b is 32, all over 2 times a, which is 2 times 2, and that's -32 over 4, which is -8, and that's what we got up here. Now we're going to take that, and we are not going to plug it into f of x, we're going to plug it into g of x. So we're going to find g of -8. So that's going to equal 2 times -8 squared plus 32 times -8 plus 5. Well, that gives us 2 times 64, because a negative times negative is a positive. And 32 times -8, well, that's going to be a negative. Let's pull out the calculator. I think I've already done this, but let's see. 32 times -8 is a -256. plus 5. And when we put this all together, we get 128 minus 256 plus 5. And putting that in, we get negative 123. And I'm just double checking. 2 times 64, 128 minus 256 plus 5, 123. We're awesome. So let's look at why does this work? Well, it has to start with the general form of perfect square binomials, as well as the standard form of a quadratic function. And so let's say we have only the first two terms of a perfect square trinomial. So we have a squared plus 2ac. And let's just also make the assumption that a equals x, and we substitute in x for the a. So in other words, it becomes x squared plus 2cx. Well, comparing this to our general form right here, where in this case, we're going to say a equals 1. Notice that, because we have a 1 right here. And keep note that the a that we've put here does not equal that same a. That we're different a's. I should have differentiated a little bit better. But we're making the assumption that this has to look like this. It does not equal. They're not the same thing. So let's say for these two expressions, this x squared plus 2cx, to equal ax squared plus bx plus c, that means the 2cx must equal bx. Those two terms have to be the same. Well, if we solve these for c, and c being the thing on the end, c must equal b over 2. Now we know the last term of a perfect square trinomial is c squared. So let's square that. So this means to make the original expression ax squared plus 2ac a perfect square trinomial, we'll need to substitute 2cx with bx and add b over 2 squared on the end to give us x squared plus bx plus b over 2 squared. If you have any questions about why it works, do not hesitate to ask your teacher, but keep in mind that you'll use the method of completing the square with not always 100% understanding exactly why. It's nice to know why, but it may take a little bit more work to make yourself understand this. Well, now it's homework time. I want you to continue practicing completing the square. It's so important that you have these steps down pat. If you're having any trouble with this, please make sure you ask your teacher. They would really love to hear from you. Well, that's the end of your video on completing the square. I hope you have a great rest of your day. Take care.